Hey everyone, our notes for today, we're going to talk about solving trig equations. So here I am, I'm going to go to tab number 5 on my folding notes that we've been using in class. If you don't have your folding notes, don't worry about it. Just write your notes down on a separate sheet of paper. Just make sure that you're copying down, whatever we see written in all of the examples. Before we get started though, what I want you to do is flip over to the back. And on the back, what I want you to do is either write, or I cheated and just printed one out, but a unit circle. We want degrees and radians and the coordinates. And the other things that I thought might be helpful is kind of reminding yourself some things about the unit circle, that cosine of theta is your x coordinate, sine is your y coordinate, and tangent is y over x. A couple of other things that are kind of nice to have on hand. We know that tangent is probably the hardest one to calculate on the unit circle. So the other thing that sometimes we might want to put is tangent of pi over 6, which is 30 degrees. Tangent of pi over 4, which is 45 degrees, and tangent of pi over 3, which is over here at 60 degrees. So what I would do is sort of calculate y over x for all of those. So what you're going to do for pi over 6, you're going to take the y coordinate divided by the x coordinate. So it'd be 1/2 over root 3 over 2. And when you end up simplifying that and rationalizing it, it becomes root 3 over 3. Same goes for pi over 4. This one's nice and easy. Tangent is 1. And then over here, y over x just simplifies to square root 3. So go ahead and pause the video and make sure that you have all this stuff copied down on the back before we move forward. So when you're ready, we're going to go back over here and we're going to go to the tab that we labeled as solving trig equations. On the top, we're going to write out some hints and some strategies, and on the bottom here, we're going to work out just a couple of examples for today. So what we want to talk about for solving, one thing we never want to do, we never want to divide by a trig function on both sides. Instead, a better idea is to get all the terms on one side and then you're either going to combine as like terms or factor. So the next thing that we're going to write on the top, we're going to talk about some things that you can do. Back when we were doing the verifying trig identities, we said we couldn't really move things from one side to the other. You can do that now. So what you can do, you can multiply both sides by the same thing, just like you would for a regular equation. You can also square both sides. That's going to be helpful in a few other sessions. And the other thing that you can do is take the square root of both sides, just like if you're solving regular equations. Remember, when you take the square root of both sides, when you put a square root into a problem where there wasn't one, don't forget plus or minus. So then some strategies. We're going to take a look at 2 strategies today. So the first strategy is just isolate the trig function, just like if you were solving a regular equation and you're isolating the variable. In this case, you're just isolating the trig function. And the second strategy that we're going to talk about today is using some of the identities to get everything in terms of one trig function. So strategy number one is just basically, just isolating the trig function just in the same way that you would isolate a variable. The second one brings in the stuff that we were doing with the fundamental identities, kind of doing some of the swaps and some of the simplifying to make the equation as simple as possible. So down below, we're going to take a look at some examples. And the instructions are going to say solve, actually I'll write it up here, solve or find all solutions in the interval 0 to 2 pi. And this is going to kind of bring back the reason that we revisited the unit circle on the back. So pay attention to your interval notation. So what this means, the bracket at the 0 versus the parentheses at the 2 pi, means that, if you get an answer of 0 or 2 pi, you'd want to say 0 instead of 2 pi, the bracket versus the parenthesis. So the first example that we're going to look at is going to be on isolating trig functions. So the example is 2 sine x minus root 3 is equal to 0. So just like you would isolate x, we're going to first isolate sine of x. So I would add root 3 to both sides. And then divide both sides by root 2. So it becomes sine of x is equal to root 3 over 2. Now this is where you're not really done after you isolate the trig function, because now what we want to do is go back to our unit circle. You have to find where is sine root 3 over 2, and where is it from 0 to 2 pi. So that means just one rotation around the unit circle. So we're going to look for where sine, where you have any y coordinate equal to root 3 over 2. So go ahead and flip it over, take a look at your unit circle if you need, but your final answer would be that the y value is root 3 over 2 at pi over 3, and again at 2 pi over 3. So there might be more than one solution to most of these. The second example that we're going to look at is an example of using identities. And this example is sine x times secant of x is equal to -1. You can see here that we don't have all the same trig function. So it's going to be really helpful here to go ahead and switch these out. So the first thing I notice is that secant is 1 over cosine. And then right here, sine over cosine, I could really rewrite that as tangent. So you're looking for where tangent, where y over x is equal to -1. So on the back where we wrote those tangent values, you know that tangent is 1 at anything that's the over 4s, the pi over 4, 3 pi over 4, all of those that are over 4. But specifically we're looking for where tangent is -1. And so that would be at 3 pi over 4, and again at 7 pi over 4. So what you're doing here is you're isolating the trig function, but then you have to say, okay, well, where does the trig function have that value? And so you can see all the answers are within one rotation from 0 to 2 pi on the unit circle. Just like I said, you're going to have a lot of times where there's more than one answer. The next thing I want you to do, I've written out some try these problems. I want you to go ahead and really try to work through these on your own. And, obviously the answers are over here. The first two are just isolating the trig function. I want you to pay special attention to this one because you're trying to find where secant is a certain value. These two here are probably going to be using identities. So I want you to make sure that you can work through these really well. And then when you're done with these, if you have any questions, please, please, please let me know. You can email me. We can set up a Zoom. Maybe I can just respond to your email, whatever it might be. When you're done with these, then you have some questions that are posted on Schoology. And again, whenever you're working on those questions on Schoology, certainly use your notes, use your unit circle. But I don't really want you talking to other people. What'd you get for number one? This really should be kind of what you can do. I also don't want you to use tutors or apps or other websites or anything. Get through these 4, and if you can do these 4, you won't have a problem with the other ones that I've posted on Schoology. So definitely reach out if you have any questions. Let me know what you think, and we'll check back soon. Hope you all are well. Miss you.